Hello, this is Christian here, and this video will be talking about the process of data flows in PHP. Well, even though the title says that, actually I'm going to just talk about the process of data flows in general that is applicable to any language. Okay, and then the subsequent videos will be diving into PHP to actually write the code to process these data flows. So first, what I want to talk about is pseudocode. This is a really a special tool kind of like to help you code. We'll talk about that in a minute. And we'll be looking at flowchart, the sequence structure, and decision structure. So pseudocode. Okay, so what is pseudocode, right? Pseudo is mean like fake or phantom, and code is the actual code, right? So you should think about it. It is a tool, or it's an informal high-level notation, or some kind of notation, or writing, or artificial and informal language that helps a programmer write code. Okay, so that is like a definition for pseudocode. And it's composed of the actual code. It can contain real code or just plain spoken words or phrases, like in any language you're most comfortable with, or just any symbol like math symbols and things like that. So whatever it is you use to help you solve a problem, that is pseudocode. And there's no universal rules or guidelines for that. Okay, but there are ways that you can write pseudocode in a very effective way to help you solve problems. So here is an example, two examples of that. The first one is this example here. As you can see, it's just plain English words. So you have a start and then you have a stop, right? Kind of beginning and end of a program. And then so it's a step-by-step process. You have to write this in a step-by-step fashion so you know exactly what's going on throughout the flow. So again, the flow of data. So you would start the program, you read the input. If the input is valid, then process the input. Otherwise, repeat and repeat the input until you get the valid process input, right? And then if input is queued, then you exit the program and you stop. So that is a example of a pseudocode to help you program. The other one here is you use some kind of, it's a mixture of actual code versus a few just, phrases that will make sense. So you have a function called is even, and you have a parameter a, and then inside that function body, you check if a is divisible by 2. So notice if a is divisible by 2, that is not an actual code. It's a mix of both. But it makes a lot of sense to you as the programmer or to another developer, right? If that is true, then return true. Otherwise, return false. So these are two examples of pseudocode. The next one is the flowchart. This is a series of shapes connected by arrows, and it provides a logical sequence of events in the flowchart. And these are some symbols in flowchart. We're not going to do all of them. The ones on the left side are the most common ones. On the right side, the arrow is important, but the bottom four are something that you may not see in pseudocode flowchart as often in programming. So the first box is the process. The process is a rectangular or a square shape. The process means like a calculation of some sort or anything that you perform in the background that does not involve a display of information or reading of information. So it's like when you receive the data, you are doing something about the data. It's a process. Okay. Then the next one down is the diamond shape. This is the decision diamond shape. A decision means that you have to choose either A or B, right? Or A or B or C or D. You have all those options to choose from. And usually in this kind of shape, there's only one input going to the diamond shape. And there's only one output can be selected from diamond shape. You can have multiple outputs. Well, usually not a multiple. It's just one or the other. Yes or no, true or false, things like that. Okay. The next one here is the terminator. So please disregard this little arrow here. This is it's not supposed to be there, but it just the oval shape that is the terminator. It usually represents the start and the end point of the program. So you will see the oval shape and then start the program. At the very end, you also see that terminator. Okay, so the next one down, the orange one is the document. That is like if you're reading a file of some sort, then you would put that in there. Okay, and the last one down on the list down there is the data. The data is that parallelogram shape, the blue shape. That one represents data. In this case, it's data, so it may be a little bit confusing, but really it's the input and output. Okay, so when you read input, you use this diagram. When you are displaying data, yes, you are printing data to the screen or to the console, you also just put this a parallelogram shape here. But the right side is the red arrow that points to another one of these shapes. So that is the flow of data, okay? And then maybe later on you'll see this little triangle shape there. That's like the storage. Things like you write it to a file, write it to a server, or write it into a database, something like that. All right. So the next one is sequence structure. It's a logical structure where one step follows another. So no chance of branching or skipping. That means it's just one way through. Okay, you're going through a one-way street or something, and there is no other option. There's no left turn or right turn options. You just follow one way through. So in this case, very similar to a navigation system. It tells you where to go, and you'll probably never hear a navigation system telling you, okay, you can turn left or turn right or go straight, right? It just says go west on A Street, turn left on B Street, continue on B Street for 3 miles, enter ramp to Highway 101 South, take exit 124, there's your destination, right? So one-way structure is very sequential. And then finally is decision structure. This is a structure that involves choosing between alternatives, a course of actions, again, back to that diamond shape, okay? And usually you have a single input and a single output. In the example here, I have a pseudocode, okay? This is pseudocode that says if the hours is less than or equal to 40, then the pay is regular pay. Otherwise, you have a regular pay plus your overtime pay, right? So it's either true or false, okay? So this is synonymous to like if you're driving down the road and you reach a T section and you have to make a left turn or right turn, right? Or if you go to a cross section, you have 3 options: either turn left, turn right, or go straight. Okay, so that would be is synonymous to a switch case statement. We'll talk about that later in the code. So again, one input and only one output is allowed. So here's an example of a flowchart that is used to calculate the overtime pay of a payroll or application, right? So you see the top is the start, and then the very bottom is also the end, and they're both using the oval-shaped terminator. And then you can see the get hours and get date. Those are the parallelogram, and they are using, in this case, they're used to read input. Okay, the third parallelogram at the bottom is used. It says print pay. That is, again, you're displaying data. So reading input and displaying input output uses the same shape. And then in between, you have this diamond shape. That is a conditional shape, condition, right? So you got to make a decision whether it's true or false, yes or no. So you test that condition in there. In this case, it's hours. When you read the hours from the input, is it less than or equal to 40? If it's yes, then you go left. Otherwise, you go right. Okay, and then in the rectangular boxes, you see those are processes. So all it does is just doing some type of calculation or operation. So therefore, it's not visible to the browser or anything like that, right? So you see when you see those rectangular boxes, that's usually exactly what happens. So inside there may be a function to do some type of calculation and so forth. And then something you didn't see in the chart is that circle in the middle down there. So that circle, that disk, well, it's a circle really. It's just a way to join all those lines together because they're related. Because as you can see, both all those rectangular boxes are actually pointing to the print pay parallelogram at the bottom. So instead of having 2 lines going to the print pay box, because you might have other ways as well from other locations that might be calling the same function to print data. So you might have 10 lines pointing to the print pay box. So instead of having all those many lines, you would just join together by having all those lines point to that circle, and then there's only one line out from that circle down to the print pay. It's just easier for us to see, basically. I mean, it's not wrong to point 2 lines to the print pay. Okay, so think of that circle. It's just like a wire or something. You could just bundle a bunch of cables together into one. Same idea. And then after you print pay, the arrow flows out to the end, and then that's the end of that program. Okay, so I hope this is helpful to kind of show you physically how things are structured, and sometimes this is very helpful to help you solve a problem. So use pseudocode, use this flowchart, and any other means you know how, sketch it out to help you solve a problem.